Dah tu, ikut lah. Done. Okay, dah done. Alright. So now can you see at the bottom product there, right?
Yes.
So there is a mixing happen, right? Mix between the Coke and your milk. But does it achieve 100% conversion? No. Because why did what will you like when it is 100% conversion? Now watch the video. They can coagulate, and that's the your final product is gonna there is a coagulation happen at the bottom part of the blender. But of course it's not going to happen here lah. But if let's say you are using PBR, because whatever that you see from the video is just pH reactor. But now this is PBR. PBR is basically like a continuous flow. Okay? How do you think that you can enhance the conversion, make it the conversion higher, better? Okay, increase the packing, which means that you need to increase, make sure that it's taller packing work. The back side, the volume of the packing is bigger. What else that you can do? If let's say you have that packing contain 10 gram catalyst and 5 gram catalyst, do you think which one will go better? The 10 gram catalyst, even though the volume size is the same, okay? Even though the volume size is the same, if let's say you put 10 gram catalyst, because sometimes when you put catalyst, you put together with what do you call it, inert material, solid material inside there together, mix up together, because you want to dilute the bag. Okay, so there is it can be like you have one big size bag volume like that, but it can have this one got 10 gram catalyst, this one got 5 gram catalyst. So what we can say that this particular reaction, it have the same gas hourly space velocity. Okay, gas hourly space velocity. Maybe you can check afterwards. What is it? What does it mean? But it has a different weight hourly space velocity. Gas hourly space velocity is always measured. It's always measured by V over V. V over V means that the volume of the catalyst bed of the bed divided by the volumetric flow rate. You will get your gas hourly space velocity. But weight hourly space velocity is basically the flow rate, the volumetric flow rate is divided by the mass of the catalyst. So you can see that even it can have the same GHSV, but it can have different WHSV. WHSV ni because one is 10 gram, another one is 5 gram. Definitely it makes a difference. So it also make a difference in terms of the conversion as well, right? So now PBR actually it behaves like a PFR. If you take out the catalyst out, so basically it behaves like a PFR, right? So you already tell that you need to increase the bed, then you can get a better conversion. Alright. So now can you go back and relate back with the mole balance equation? Okay. In minus out plus generation equals to accumulation. So there is an in and in, there is an out as well, right? It goes in and it goes out. Is there any accumulation? No, there is no accumulation because it's a continuous flow. There is no accumulation there, so it's flowing, right? So you have to arrange back the equation such that, except that instead of you put it by dV, the terms is by dW because it is with respect to the weight of the catalyst. So weight of the catalyst is very important here compared to the bed size itself. Okay, so now we have done already. We have done on PBR, and we have done on the PFR. And I've talked to many of you already here. The PFR, when they make the experiment of PFR, they can see that the concentration change along the length. And supposedly pun, when you use this PBR, the concentration will change along the bed until you reach the final part. Okay, along the bed they can change concentration, right? But for CFCR, whenever you inject into the reactor, and then it transforms magically straight away to the final exit concentration. So that's why if you relate back to the mole balance design equation, you will understand why this is derived like this and PFR is derived this way. Okay, And we also make just now we look into CSTR, one using small size CSTR, another one using big size of CSTR. It makes different. Okay, a bigger reactor will give better yield and conversion. Okay, so if let's say you want to extend, you want to have a higher conversion for your BFR, you need to have a longer tube. If you want to have a bigger conversion for your CSTR, bigger tank of CSTR. But does it affect for batch reactor? No. Batch reactor only depends on time. Okay, you got that concept. That's good. Alhamdulillah. Right? So, any question? Any reflection they want to share? Anybody like to share anything? 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 Without say something? How do you find the activity today? I'll let you get Faris from Faris afterwards.
Yeah, the activity today is fun, okay? Because we get to create stuff and it excites our creativity. But at the same time, we learn something about our project. And so after we migrate from one spot to another, we can learn about others' project as well. Okay? It's interesting because you can see like instead of theory and on paper like diagrams, and you can see in 3D and do the experiments yourself.
We have Jan here. Jan kat sini, kan? Jennifer. Ah yes, Jan. Sorry, I didn't see you. Was the
Hi everyone. Well, I feel today's activity was rather interesting. Besides what we just studied the theory parts and all, now we actually get to do reactors, and when we look around with other people's stuff, and also we are creative enough to form such a things like that all. And I think this will make us remember more, like, and as you said earlier, in the team building according to the cone. So this is as well, we are repetitively like teaching people and all how, so it will be inside our brain, so we will not forget like that. So
Hi. So today I feel so excited because we have learned to do the reactor by ourselves. And for me, creativity is all about everything because we want to use the minimum amount of coke and everything so that we don't waste, so that maybe some of us want to drink after that. Yes, we have some. And then instead of just learning like what Firdaus said, instead of just learning the diagram and also in the class, we have learned to do it ourselves, and we use our minds, our fresh minds, to do this kind of reactor by using bottles, just bottles. And for me, it's kind of a great outcome that comes from this activity, and thanks to Dr. Tazli and also the assistant. It was such a great activity for all of us.
one last from the girls. Siapa ada nama sini? Hidayah dalam grup ni ke? Bukan. Batrisha dalam grup ni? Bukan. Siapa nama? Ada nama Aida tak sini? Aida ada dua?
Tiga. Tiga.
Aida.
What's that difference today that we can learn how the reactor that in real life, so that it can make our for a better understanding now.
Enhance your understanding. Okay, so alright. Next week there is no class on Tuesday.